record so we can record this. One of the first things we're going to do is take our, remember that our line, our asymptote would be at 0, 0. We're going to move that up 1 because of this plus 1. Okay. So up, 1, up. All right, what does this piece mean, friends?
Right 3.
Right 3, good. All right, is this growth or decay?
Growth.
Growth, good. This is going to be growth. And what is this pesky 2 going to do out front? Is this a stretch or a shrink?
Stretch.
A stretch, good. It's a vertical stretch because it's on the outside. It's not affecting that piece. Okay, so over to the side, I'm going to use my X and Y table, and I'm going to use just 2 points because that's all I want. And I'm going to take this and I'm going to pretty much strip it down to just the growth factor and the X, because the rest I'm going to translate later. All right, so 2 to the 0 is 1. 2 to the first is
2.
2. And then I want to go back and I want to multiply by
2.
a negative or a positive 2. I'm sorry, thank you. So I get 2 and 4. And then I'm going to take, oh, go ahead.
How'd you get 1 from a 0?
Because any number to the 0 power is 1. Good question. Great question. Okay, so here's your X and your Y. I'm going to use my pink right here, just to graph. All right, I'm going to graph 0, 2, and I'm going to graph 1, 4. 1, 2, 3, 4. And then I'm going to take those and move them 3 to the right and 1 up. 1, 2, 3, 1 up. 1, 2, 3, 1 up. Does that look like I'm growing here? Okay. What's my domain, friends?
All reals.
All reals. Oh man, so sharp this morning. I love it. All right, and how do I want? I want 1 and above.
Y is greater than or equal to 1.
Careful. Do I want to hit this line?
No, it's all greater than. Okay.
Good. Thank you. Thank you. Thank you. Good job. Thanks for taking that risk. Awesome. Okay, so you're like, I got this. Okay, so let's just throw in there a horizontal. Okay, and we did this before, but it was kind of weird, and I didn't like how I presented it last year. So I think all of these transformations will make sense, make way more sense than it did before. So I'm going to just keep it, I'm going to keep it on growth, okay, friends? So I'm going to do g of x is equal to 3 to the 3x minus 5. Okay. Don't freak out, okay? Not a big deal. Okay, but you'll notice that there's no multiplier out front. The multiplier is located right there. Okay, so before you even get started, look at your growth factor and tell me, is this growth or decay?
Growth.
As growth, good, because it's a 3. Okay, it's growth. And tell me what this x minus 5 is going to do. Just the x minus 5, not the 3. So I'm 5 to the
Right.
Right.
right. Do I have anything added off to the end or subtracted?
No.
No. So that means I'm not moving up or down, am I? Okay, so that means I'm going to take my pink and I'm going to put my asymptote. It's always good to know where your asymptote is. Okay, I'm going to put that at 0 because I haven't moved up or down. All right. I'm still going to use my same points. Okay, I'm still going to use 0. Okay. And I'm still going to think about it like this. Okay. So what is 3 to the 0 power?
1.
1. And what's 3 to the first power?
3.
3. Okay, now I'm going to color this in a different color. Okay, now because notice that this is affecting the x, right? Okay, this is a horizontal shift. Now, I'm going to put a star. I'm going to make it all colorful so that you can see. When you have a horizontal shift, the first thing you need to do in order to understand the horizontal shift, you need to flip the number. So what I mean by that is I'm not affecting this by a factor of 3. I'm really affecting the x by a factor of 1/3. Okay, here's what I mean by this. Come on.
So basically, if there's no number at the end of the problem, like if you're not subtracting or adding it, you're flipping the number because it's horizontal.
No. I'm flipping the number when I'm multiplying the x. Okay, that's the part. The reason I didn't shift up or down,
It's because of the number.
the reason I didn't shift it up or down is because I
Yeah.
didn't.
Yeah.
Yeah, I didn't have something. Sorry, I'm trying to look for. I was trying to look for a piece of string here to show you what I mean. Okay, so we're going to take this growth function. I know this seems really weird, but you know, I'm really weird to begin with, so it's okay. Okay, so when you think about a vertical stretch, okay, vertical, I'm stretching this vertically, right? Right? Did you see how I moved this vertically?
Yeah.
Makes it okay. But when we talk about a horizontal stretch or shrink, think about it like this. It's this way, right? Or a horizontal shrink actually means it's going to be steeper. See, I'm stretching it this way. I'm shrinking it this way or stretching it out this way. I was doing this with parabolas. Okay, so if I want to do a horizontal stretch where I'm going to stretch it out horizontally, then I'm going to move. Do you see how it makes it bigger? Or a horizontal shrink means to move these closer. Okay, so the whole idea is that you need to do a flip. if it's a multiplier of 3, in order to affect the slope, and if you think about slope as y over x, I need to flip the number first and then multiply not the y values, but the x values. Okay? So the first thing I need to do is I need to flip the number. So instead of a 3, I'm going to multiply by a third, because I want to affect the x, the y over x. Okay? And then I'm going to multiply all the x values. Well, 0 times a third still gives me 0, right? But 1 times a third gives me 1/3. All right, let's highlight our new x values and my y values. Okay? So I just took this graph and I just made it skinnier. Okay, so I'm gonna go ahead and I'm gonna graph, and then I'm gonna do my 5 to the right, okay? So 0, 1, and then this is a third and 3. 1, 2, 3. Wow, that just got really, really skinny. And now I'm gonna shift the whole graph 5 to the right. 1, 2, 3, 4, 5. This is 1, 2, 3, 4, and 5. Whoa. I had to really make that go up fast. Domain.
All reals.
All reals. Range. Come on now, my pink line.
Greater than 0.
Greater than 0, thank you. Okay, so the only new thing on here is looking at that multiplier. Flip it and then multiply your x's. This looks different, look at, than this up here, doesn't it? This 2 was out front. This is affecting up by the x. Okay, so it'll be a multiplier up there by the x.
Mrs. Bassett,
Yes. I'm still going to have an asymptote. Now, notice that there's nothing on the outside, so I'm still going to put an asymptote of 0. If you put on your calculator, e to the 0 power, okay? If you want to know how to do that, oops. So I'm going to clear second function. E to the 0 power is still 1. So my graph still goes through 0, 1. And if you do e to the first power, it will give you, oh, it's 2.18. 2.718. So my next graph here is 2.718. Looks good. Oh my gosh. What did I just draw? What shape is this?
Growth.
Growth function. Well, when you stop and think about it, if E stands for 2.17, isn't that bigger than 1? So of course it's growth. So guess what? The domain is still
all reals.
real.
reals, you got it. My range,
Oh,
y
yeah.
is
Y is greater than 0.
awesome. See? No big thing. Well, guess what? can make this also be a decay function. Watch this. Now, when you stop and think about this for a second, anything to like this -1, that makes stuff flip, doesn't it? Okay, so these are really, if you wanted to put these in their own like box, you know, these are really the parent functions of these guys. All right, so did I add anything off to the end?
No.
Nope. So,
No.
all right, my asymptote, it's good to know where your asymptote is. Okay. All right, my numbers 0 and 1. Okay, got your calculator? Well, what's e to the 0 power?
1.
1. But what happens when you do e to the -1st power? What do you get on your calculator?
Small.
A decimal. What? Now, are you rounding a little bit? Yeah. All right, so 0, 1, and 1 and only about 1/3. Oh my gosh. What did you just graph?
Decay.
Decay. What made it decay?
The negatives.
There you go. I'm going to make this green. So could I just say, hey, whenever there's a negative exponent with an e, it's going to be decay. Whenever there's a positive, it's growth. Could I say that?
Yes.
Absolutely. Yes. That's as easy as it gets, friends. That's as easy as it gets. And so now when you stop and think, I can add all of those movements and translations, I can throw them on here. And it doesn't matter because I'm still moving it in the same direction. It's okay. Okay, I'm still moving it everywhere. So let's do one together that we're putting it kind of all together. I'm going to do, let's see, what do I want to do on this? I think I want to do a horizontal translation just to practice that with you guys. So let's do this. Y is equal to, well, you know what? I'm going to do it all. 2e to the 1/2 x minus 1 plus 1. Okay. I keep hearing like dings, and I'm not sure if I'm just getting a bunch of emails or what. Okay. All right, let's color code all of this, okay? Let's take care of, let's do these two pieces, first of all, right here. And I'm gonna do this. Now, why did I put this in pink? Because what am I gonna draw?
Asymptote.
Yes, good to know where my asymptote is. Good job. All right, the purple here, x minus 1, that's 1 to the?
Right.
1 to the right, thank you. All right. So before you get going any farther, tell me, is this positive or negative, friends? Is it half positive? So is that growth or decay?
Growth.
Growth. So put that down, growth. Just so that you know which direction it should go, okay? But this 1/2, this pesky 1/2 that's up there, that's affecting the horizontal, isn't it? And I'm running out of colors. The 2, that's a vertical stretch. So I'm stretching it vertically, I'm doing stuff to it horizontally, all that good stuff. I'm still
We don't flip the number,
done.
huh?
Did you say switch the number?
No, flip the number.
Oh, we're totally gonna flip that number. Well
Well-
done. So instead of 1/2, we're gonna do
2.
a 2. Do I flip this number?
No.
No, I do not. Okay. Wow, you already got me on that flipping the number. Good job. But let's just do this. Plain Jane, e to the x. Let's just do this. So what's e to the 0?
1.
E to the 1st.
0.37.
2.718. Yep. All right. Now take care of all this. Okay. So let's do this off to the front. What's 2 times 0?
0.
What's 2 times 1?
2.
So let's highlight those. Those are going to be my new X values. Let's multiply these. 1 times 2 is 2. What's 2.718 times 2? It's going to be a little bit bigger. Help me out, friends.
5.436.
Thank you. We're going to highlight those. All right, let's graph. 0, 2. 2 and 5.436. 1, 2, 3, 4, 5.436. And then we're going to make sure that we translate, right? 1 to the right and 1 up. 1 to the right, 1 up. 1 to the right, 1 up. Okay, domain.
All real.
All real. Range.
Greater than 1.
Greater than 1. Well done. I know this was a lot, but you guys tackled it. Very good. Really good. I'm really impressed. Okay, I am only asking to see on graphs 0 and 1, and that's it. Okay, for that piece. And really, your job today is really to look at and just getting the translating piece and growth and decay with your E values. Okay. So I'm going to go ahead and